picture this. In a world where every second counts, where a simple mark on your skin could rewrite the course of your life, we have all witnessed the toll of late diagnosis, the pain it inflicts on our loved ones. But what if there was a way to alter that narrative? Today, I invite you to step into the realm where time becomes an ally, not then. Introducing Dermavision, the future of skin pathology. Skin cancer is a widespread occurrence. According to NHS, there are 3 million people diagnosed annually, out of which only 0.25 million people are cured. It has a mortality rate of 33.33%, and early detection of skin cancer increases the survival rate from 32 to 98%. Now comes the million-dollar question. How do we detect skin cancer faster? A major block in this process is the process of biopsy analysis, which heavily relies on slides to be examined before being, which heavily relies on the slides to be stained before being examined. So first off, when the tissue is extracted by a biopsy, it's fixated, embedded, and then it's passed through, certain chemicals are added to histologically stain the slides. After the staining step is performed, the slides are then used by the doctor for their examination. This is a manual process, and it's both costly and time-consuming, not to mention it's toxic to the aquatic environment, and histopathologists are required for validation in areas where there might not be one available. So what we proposed Dermavision, whereby we use state-of-the-art artificial intelligence models, algorithms to virtually stain whole site skin images. So after the biopsy is done, the unstained tissue sample is fixated, embedded, and instead of adding chemicals, it's passed through an AI algorithm which generates a virtually stained image. This process is known as virtual staining. Here's a complete, so Dermavision is a platform for histopathologists to digitally stain whole site skin images, identify cancerous region, and manage all data via the cloud-based web application. So here's the complete overview of Dermavision versus the conventional process. Dermavision goes one step further. After virtual staining, doctor has the ability to pass that stained slide through another neural network for segmentation. In doing so, the segmented mask, confidence heat map, surgical margin clearance are all generated, which the doctor can then use for their evaluation and diagnosis. Now to Hamid.
So, thank you, Tayyip. Now for this very scary looking diagram actually. So what we basically propose to do is that for solving the entire staining mechanism, how do we do that? The issue comes in processing whole site images. Whole site images are very large images, sometimes ranging up to 500 MBs. So for processing that, we have to make patches, and then we have to feed them forward to our generative model. We are using a custom generative model which utilizes contrastive learning to maximize the cross-domain learning in both of these cases. In our case, the unstained and the stained maps. This is then, when doing inference, we run basically sort of the same thing but in reverse. We get the patches from the input image. They are then fed forward to our GAN model, the contrastive learning GAN model that we trained, and which generates the results. And then using alpha blending, we sort of merge them back together for a smoother prediction. Right, so this is sort of some visual proof of our results. So you can see the HND stained in the laboratory in the top row, and the virtually stained in the bottom row. The mid one is the input data. This basically shows that there is visual closeness between both of these domains, and the solution can work as we show later. We have done qualitative and quantitative results on it as well, assessments on it as well. So for a segmentation workflow that we mentioned, to assist the doctor in diagnosing the disease, we move forward and add a second model, one with an FHNet encoder and a UNet decoder, to sort of create custom masks which shows the individual layers, and if cancer is present, then in what layer is it present, to sort of aid the diagnosis. This again has to be processed via patches, and we are using overlapping patches to get the information about the previous patch as well. Right, so for our unique aspect would be displaying the following to the doctor basically: the stained image, afterwards the segmentation mask along with the confidence heat map. So this basically, confidence heat map addresses the issue of explainability in medical AI applications, and also a surgical margin clearance, which indicates to the surgeon that how far has the cancer spread, essentially. So, in order to check the stability and reliability of AI algorithms, 3 board-certified graders did a blind study, a blind 2-phase study for evaluating our results. In the first phase, single virtually stained slide patches were assessed. In the second phase, virtual and histological stains were compared side by side. In the first phase, the graders achieved an adequate rating of 88%, a mean adequate rating of 88%, along 10 different classes such as color, resolution, sharpness, contrast. In the second phase of study, whereby both of the samples were taken side by side, they achieved a mean agreement that both can be used interchangeably of around 82%. So our magical AI is deployed on a web application based on the cloud. Its front end is coded in React.js and it's deployed on Firebase. The back end is coded in Flask and it's deployed on Google Cloud Platform. It's HIPAA compliant, which ensures that patient data security is managed. Right, so this is what the doctor would have at the end of the screen, which we would later show in a demo as well. So they can download anything which they need to make the diagnosis after that. So the applicability of this is both in surgery and medicine. In surgery, in advanced operation theaters, whereby quicker diagnosis and around the time decisions have to be made. Furthermore, in computer-aided surgery as well. In medicine, it can be used in teaching facilities and also assistive diagnosis. So, did you know that approximately 3 million styles are stained with H&D stain daily? This translates to a whopping market capacity of $21.3 billion, of which 60% is the cost of H&D kits and consumables. In Pakistan alone, this is around 75 cancer treatment facilities with each each slide costing around $3 to $6, and there are only 29 histology training centers.
Thank you, Hamid. So, just a second. Here's some testimonials from our highly respected doctors, both of whom see Dermavision as a game changer in the field of dermatopathology. We have received multiple international and national recognitions for our project. The innovation and novelty of our solution is reflected in 2 journal articles, a copy of which is now being shared with our esteemed judges. We have collaborated with multiple with industry leaders from across the world, from Pakistan, USA, Australia. Our core team members include experts from medical, image analysis, and AI. We have a pool of medical advisors to help us in validating our results and provide key valuable insights.
So that does seem like a lot to take in. So let's just read a quick refresher on the entire thing and also have a quick demo.
Skin cancer affects millions of people worldwide, and accurate diagnosis is crucial for effective treatment.
However, the current methods of analyzing skin tissue samples pose significant challenges. Manual staining, the traditional process used to enhance tissue samples, is not only time-consuming but also prone to inconsistencies. Moreover, the staining process is costly, adding to the burden of healthcare systems. Introducing Dermavision, a groundbreaking cloud-based application designed to revolutionize the field of dermatopathology by leveraging the power of artificial intelligence to enhance the process of analyzing skin samples. Let's have a live demo to showcase the power of Dermavision. Here is the user interface that provides a seamless experience for dermatologists. Doctors can choose between performing staining or segmentation, wherein the staining process is accompanied by segmentation. We navigate to the staining button and click on it. Next, we upload an unstained skin image, which would typically require traditional staining in a lab. Dermavision quickly processes the image and generates a stained version in real time by utilizing the concept of Deep Cross-Domain Learning Generative Adversarial Network, or DCL-GAN. Our model is equipped with a custom loss function that maximizes cross-domain learning. After staining is complete, the doctor may choose to send the resulting image for segmentation by clicking on the segmentation button. It provides precise segmentation of 12 different classes within skin samples. This includes the identification of 3 major cancerous classes: basal cell carcinoma, intraepidermal carcinoma, and squamous cell carcinoma. After a brief processing time of approximately 1 to 2 minutes, Dermavision provides a segmented mask and the uncertainty heat map of the stained image. It also provides surgical margin clearance indicating the cancerous region and its spread. Equipped with these images, dermatologists can now perform in-depth analysis, aiding them in making accurate diagnoses and treatment decisions. Dermavision offers several significant benefits to the field of dermatology, like cutting back on time, eliminating the need for traditional staining techniques, reducing costs, and preventing the use of toxic chemicals.
Project is that it reduces staining costs, it prevents aquatic pollution. In areas where histopathologists are not available, it leads to quicker diagnosis, and early detection again increases survival rate from 32 to 98%. Now, having seen firsthand how this disease destroys not just individuals but families, we aim that our solution would be extended to other domains and would ensure faster diagnosis and health for all. That would be it. Thank you so much.